Hey everybody, today we're going to talk about residuals in relationship to scatter plots and what is a residual and what does it do. Alright, the first thing I need you to do though, this part that says warm up, you can go ahead and mark through that for me, and please do mark through it. Alright, so what is a residual? So it says that a residual is the difference in the observed value of the response variable y and the value predicted by the regression line. In other words, it shows how far each data point falls from the regression line. So basically, you don't deal with residuals unless you have found the equation for the line of best fit. So if you'll remember in previous lessons, we have used the graphing calculator to come up with the equation for a line of best fit, a linear regression equation. Okay, and so the residual is going to tell us how far each individual point is from that equation. Okay, then we have something called a residual plot, and that's just another scatter plot that we can make that compares the x values with the residual values, with how far we are from the line. Why do we care about all of this? The residual will help us to assess the fit of a regression line. Basically, it just helps us know, is the line that has come up, is that a good line for this data, or should we have maybe not done a linear equation? Maybe we should have done a different type. It says, along with the correlation coefficient, which you know is R, not the residual, a residual plot can tell us whether or not our trend line is a good fit. If the regression line captures the overall relationship between x and y, the residuals should have no systematic pattern. In other words, if the residual plot doesn't have a pattern, then we say a line works for this data. If the residual plot does have a pattern, then we say it shouldn't have been a line. We shouldn't have been calculating a line. It should have been something else, maybe an exponential or maybe a quadratic equation. Okay, here are 3 examples. So in this first one, it says the residuals are randomly, these are all residual plots. The residuals are scattered around. Therefore, this is a good fit. Okay? In the middle one, it says the residuals are kind of spread out. All right? And this just means the line of regression isn't so great. It's okay, but if the x values are super large, not so much. The bottom one, we definitely see a pattern here. In this case, a curved pattern. So therefore, this is not supposed to be linear. Okay? So if you came up with a linear regression equation for that data, then that's not the best type of equation you should have done. Maybe it should have been quadratic or exponential or what have you. But in short, all I need you to know is the line of best fit, is that a good fit for the data? Should it have been linear or something else? That's all that you're needing to be concerned with. So let's jump to it. So let's look at some practice here. So, looking at number 1, it says the data given below shows the height at various ages for a group of children. So they've got a table. Given the best fit line as y equals 0.634x plus 64.945, part A, and there's only one part, is there a pattern and is this a good model? So basically, what they're asking us to do here is fill out the table, okay? Using this equation, they're wanting you to plug in the x values into this equation, and then that will give you the corresponding predicted values. Once you have the predicted values, then you subtract the predicted values and the actual values to get an individual residual value. A lot of information, right? All right, let me show you how this would look on Desmos. So in order to do this on Desmos, first thing you're going to have to do is the same first step that we've done before. So we're going to go through and enter our data from the table into Desmos. So I'm going to go ahead and enter my x values, so 18, 19, 20, and these all go in order all the way up to 29. So I can just keep hitting that blue arrow and get all that. Now my y values are 76, 77.1, 78.1, 78.3, 78.8, 79, 79.4, 79.9, 81.3, 82, 82.6, and 83.5. Now I can see that I have made a mistake here, so I'm going to go back and I'm going to see which one did I miss. 76. Okay, this one should be 81.1, then 82, then 82.6. Okay, and then my last one is 83.5. There we go. All right. So, there we go. So now I'm going to come up. I'm going to ask the calculator to give me the equation, a linear equation, just like we've done previously. Okay, so here I have the linear equation. Now this is the part that is definitely different. Do you see where it says residuals, and then you see E sub 1, and then you see plot? You need to tap on the word plot, and as soon as you do that, look what happens. You get this table right here. So, or this extra column in your table. So you have the x's, the y's, and then the e sub 1s. The e sub 1s are the residuals. So those are the values that you would fill in the table here on the worksheet where it says residual. All right, but we want to see the residual plot, right? So here's what we need to do now. So when I zoom in over here, I've got blue dots that are going with my purple line, and then I've got these black dots. Okay, well the blue dots are my y sub 1. If I tap on it, then the blue on the y sub 1, see when I tap there? And I'll come over here so you can see. When I tap right here, then they go away because I don't need to see them. And I also don't need to see my purple line, so I'm going to tap here so my purple line goes away. See that? So I'm going to get rid of that. All I want are to see my residual plots, which are the black dots. So let me move over here, and I'm going to zoom a little bit more so you can see what's happening here. Okay. So this data, okay, it looks a lot like what we see over here. You see the residual plot that they already made. So the question is there a pattern? Is this a good model? Would you say that there is a pattern to this data? Okay, and if so, is it a good model or not? Well, for this particular data, we'd say there's not really a pattern. Is there a pattern? We're going to say there is not a pattern. And we're going to say it is a good model. Okay, and that's it for that. So if there is not a pattern in that residual plot, then we can say it is a good model for the data. All right, so now we're going to get ready to try another one. Okay, so let's look here at number 2. All right, so we have our table again. And, let me go back real quick. I'm not going to make you fill in this part of the table. Just mark through that for me. And then for number 2, same thing. We're not going to fill in this part. I'm not going to make you do that by hand either because we're going to use the technology to help us. So part A says if y equals 26.732x plus 16.226, plot the residuals after filling in the table. So we're actually not going to plot the residuals either, because we're going to do that on the graphing calculator, on Desmos. All right, and then it says, based on the residuals plot, is a line a good fit of the data explained? Well, in order for me to be able to determine whether or not that line of fit is a good fit for the data, I'm going to have to enter that data into my calculator and follow the same steps I did before. So I'm going to get my table, and I X'd out the other stuff that I had before. So go ahead, if you didn't already do that, X those out. So my X's are 5, 5, 3.1, 6.8, 6.2, 5, 6.8, 5.5, 4.1, and another 4.1, 4.8, 1.5, 5.6, and 5.1. And then my Y's are 195, 96, 90, 188, 183, 166, 200, 161, 72, 157, 137, 68, 192, and 156. Okay, now we're going to ask the calculator to give us the equation for the line of best fit. So let's finish entering that in. Okay, so now we've got all that. Now we want to see the residual plot. So remember where it says residuals, I have E sub 1 and then plot. Tap on plot, and then we can see that the E sub 1 values are going to be those red dots, which are right here. We're going to get rid of the blue dots. We don't need to see them because we're just looking at the residuals. And I also am going to tap so that I don't... my equation, I don't need it to be graphed. Here we go. There we go. There. Okay, now that's off. Okay, so all I'm seeing are my residuals. Well, it's really hard to see this. It looks like it's in a line, a vertical line that is, right? So I'm going to say, on my question is saying, based on the residuals plot, is a line a good fit of the data, and explain. And so do you see a pattern here with this data? Well, we actually kind of do see a pattern with that data. It kind of looks like it's more vertical. So that would indicate that this is a line would not necessarily be a good fit for this data. And if you go back and look, I'm going to plot the, hold on. There we go. Okay, I'm plotting the blue points, okay, along with my equation for the line of best fit. You know, you can see that that line does go with the data, but it doesn't, it looks like it's going to be more exponential, right? So the red dots that we're looking at, remember that they're the ones that we're using to determine the fit, okay? So based on the residual plot, is a line a good fit for the data? And we're going to say, no, a line is not a good fit for the data. Okay, and how do we know that? So we could say there is a pattern to the residual plot. Remember, if there's a pattern to the residual plot, then we are going to say that a line would not be the best fit for the data. You don't have to know what would be a better fit, just that a line is not a better fit, okay? Not a single straight line. All right, so now what we're going to do is we're going to go to the next page, and I want you to do number 3, and I want you to do number 4. Whoops. Now, for number 3, You do not have to fill in this part of the table, and I actually don't even need you to make a residual plot. So you can mark through that. I just need you to find the equation, is what it's asking you to write down the equation and the correlation coefficient, and then tell whether or not there's a pattern. And then for number 4, that one's self-explanatory. So go ahead, I want you to pause the video and do problems 3 and 4 now. Okay guys, welcome back. We're going to check over problems 3 and 4. Now remember, for problem 3, I told you didn't have to fill in the table and you didn't have to fill out the residual plot because we were going to use our Desmos to help us get that information. All right, so here is our equation, and I did round in the equation, and for my correlation coefficient, I rounded to the nearest hundredth for those. So go ahead and pause the video and check over number 3. Okay, and then number 4. Go ahead and pause the video and get that down. Okay, hopefully you've done well with today's lesson. If you have any questions, just don't forget to bring them to my attention. I'm happy to help. You can go ahead and turn this assignment in and then work on your independent practice. Good luck.